Io. Io is Jupiter's innermost large moon, and it holds a title that sounds impossible until you look at the numbers. It's the most volcanically active body in the entire solar system, not compared to other moons, compared to everything. More active than Earth, more active than anything else we've found. The reason comes down to location. Io is caught in a gravitational tug-of-war between Jupiter's enormous pull and the competing gravity of Europa and Ganymede. That constant back-and-forth squeezes and stretches the moon's interior the way you'd need a ball of dough, converting mechanical stress directly into heat. And that heat has nowhere to go except up. So the surface bleeds. Volcanic plumes erupt hundreds of kilometers into space. Lava lakes pool on the ground. The terrain shifts, cracks, and gets buried under fresh material almost continuously. The surface is coated in sulfur compounds, yellows, oranges, deep reds, and it looks almost painted. But that color is just chemistry. Sulfur at different temperatures and oxidation states produces different colors, and Io cycles through all of them constantly. The detail that lands hardest is this. Io has no impact craters. Not because nothing hits it, but because the eruption rate is so fast that any crater that forms gets filled in and repaved almost immediately. The entire surface is geologically brand new. Whatever history Io has is buried under hundreds of layers of lava and sulfur deposits. It's a moon with no memory. Io's problem is too much geological energy. Europa's problem is almost the opposite. It's geologically quiet, but what that silence is hiding is deeply unsettling. Europa. Europa is slightly smaller than Earth's moon. From the surface, it looks almost featureless, a smooth, pale shell of water ice with a few reddish-brown streaks cutting across it. It's one of the least dramatic-looking objects in the solar system. What's underneath it is something else entirely. Below that ice shell, estimated to be between 10 and 30 kilometers thick, there's a liquid ocean, not a small one. It may be around 100 kilometers deep, and the total volume of liquid water it contains is larger than all of Earth's oceans combined. A moon smaller than our own is holding more liquid water than our entire planet. The same tidal flexing that tears Io apart works on Europa too, just more gently, enough to keep that water liquid, but not so violent that it rips the surface open. The reddish-brown lineae, those cracks across the ice, are places where warmer material from below pushed through and refroze at the surface. The ocean is communicating with the outside world. Very slowly, but it's there. Strip away the excitement and look at what you're actually describing. An ocean completely sealed under kilometers of ice, no sunlight, no connection to the surface, bathed in charged particles that would be lethal to most life as we know it. Whatever is down there has been isolated in total darkness for potentially billions of years. Europa is disturbing because of what might be there. Enceladus is disturbing because of what definitely is. Enceladus. Enceladus is small enough that it would fit inside the continental United States. It is not, in any obvious way, a moon that should be doing anything interesting. And yet Saturn's E-ring, that faint outer ring stretching across millions of kilometers of space, is made almost entirely of material that came out of Enceladus. The South Pole is split by a set of long, parallel fractures called tiger stripes. Each one runs about 130 kilometers long and 2 kilometers wide, and they run warmer than the surrounding terrain. Out of those fractures, geysers blast continuously, not intermittently, not occasionally, but all the time, shooting water vapor, ice particles, and organic compounds hundreds of kilometers into space at roughly 1,400 kilometers per hour. That material feeds the ring. Enceladus is actively building a planetary feature from its own interior, and it hasn't stopped. The Cassini spacecraft flew directly through those plumes and found water, salts, silica, hydrogen, and complex organic molecules. That's the chemical signature of hydrothermal activity, rock reacting with hot water deep on the seafloor, the same process that supports entire ecosystems around deep-sea vents on Earth. We already flew through whatever is happening inside Enceladus. We sampled it. We just didn't fully understand what we were passing through at the time. Titan. Titan is bigger than the planet Mercury. It has a thicker atmosphere than Earth at sea level. That atmosphere is mostly nitrogen, which is the same as ours. If you were designing a planet from scratch using Earth as a template, Titan would look at first like you were on the right track. Then you check the details, and everything falls apart. The surface temperature is around minus 179 degrees Celsius. At that temperature, water ice is as hard as granite. It functions as bedrock. Methane behaves the way water does here. It evaporates, forms clouds, and comes back down as rain. Titan has rivers carved by liquid methane and lakes. Its largest sea, Kraken Mare, is roughly the size of the Caspian Sea, filled not with water but with ethane and liquid methane. If you fell in, you'd freeze before you drowned. Across the equatorial regions, dunes stretch hundreds of kilometers, the same long parallel ridges you'd see over the Sahara. But they're not made of silica. They're built from organic hydrocarbon particles that form when sunlight breaks apart methane high in the atmosphere, then drift down and pile up over millions of years. The sand is a byproduct of atmospheric chemistry. Titan doesn't feel hostile the way a vacuum does. It feels wrong in a more specific way. Like every process that makes Earth livable ran through the same steps but with completely different ingredients. Weather, erosion, seasons, surface liquids, all present, all toxic. Miranda. Miranda orbits Uranus, and the first thing you notice is that something went very badly wrong. The surface looks like it was broken into large pieces, shuffled, and reassembled without a reference image. Smooth plains run directly against ancient, heavily cratered terrain. Canyon systems cut through both. Scattered across the surface are structures called coronae, large oval regions filled with layered, grooved terrain that don't match anything around them and don't resemble geological features found anywhere else in the solar system. Verona Rupes drops about 20 kilometers straight down, the tallest known cliff in the solar system. On Miranda's low gravity, an object falling from the top would take around 10 minutes to reach the bottom. It doesn't look like erosion created it. It looks like a seam, two completely different pieces of terrain pressed together with the edge left exposed. One leading theory is that Miranda was hit by something massive, shattered, and slowly pulled itself back together under its own gravity. But gravity doesn't care about order. Deep interior material ends up at the surface. Surface material gets buried. Different terrain types land next to each other with no geological logic. The moon comes back wrong. Some models suggest the coronae formed through internal convection rather than catastrophic impact, which doesn't make the picture cleaner. It just means Miranda's interior was churning in ways that produced features with no equivalent anywhere else. Either it was destroyed and rebuilt, or its own geology is deeply strange. Both options lead to the same result. Triton. Triton orbits Neptune backward. Every other large moon in the solar system orbits in the same direction as its planet's rotation. Triton goes the other way, and that single fact unravels almost everything about how it got there. It wasn't formed with Neptune. Current models suggest it was a Kuiper Belt object, essentially a dwarf planet, that wandered too close to Neptune billions of years ago and got pulled into orbit without enough velocity to escape. So it stayed. But an object in a retrograde orbit can't stay stable forever. Tidal forces are slowly pulling Triton inward. It's losing altitude on every pass. In roughly 3.6 billion years, it will cross the Roche limit, where Neptune's gravity becomes strong enough to pull it apart, and the debris will spread into a ring system. Triton is already in the process of being destroyed. It's just on a very long timeline. The surface sits at around minus 235 degrees Celsius, close to absolute zero, covered in frozen nitrogen. And yet, it has active geysers. Solar heating, faint as it is that far from the sun, warms subsurface nitrogen just enough to vaporize it, and it pushes through the crust in dark plumes several kilometers high. A moon near the thermal floor of the solar system, cold enough that nitrogen freezes solid on its surface, is still geologically active. Stack everything together, a captured body from the outer solar system, in a decaying retrograde orbit slowly spiraling toward destruction, with geysers erupting from a surface that's barely above absolute zero, in a region where sunlight arrives too dim to read by. Triton isn't settling into Neptune's system, it's just counting down. Iapetus. Iapetus orbits Saturn with one hemisphere, jet black, and the other bright white, a contrast so sharp it looks like two different moons fused together. Giovanni Cassini spotted it in 1671 and couldn't explain why it nearly vanished on one side of its orbit. The answer turned out to be stranger than anyone expected. The leading hemisphere sweeps up dark reddish dust as Iapetus moves through Saturn's outer debris field. That dark material absorbs sunlight more efficiently than the surrounding ice, so it warms up. When it warms up, water ice beneath it sublimates, turns straight from solid to gas, and that vapor drifts toward the colder, brighter trailing hemisphere, where it refreezes. The dark side gets darker, the bright side gets brighter. The process feeds itself over billions of years until you end up with a contrast that looks artificial. One side is roughly as reflective as fresh snow, the other is roughly as dark as coal. Both are the same moon. And then there's the ridge. Running almost exactly along the equator, a mountain chain rises about 20 kilometers high and stretches for over 1,300 kilometers. It's one of the tallest mountain ranges in the solar system, and it sits on a moon that shows no other signs of the kind of geological activity that usually builds mountains. Current models can't cleanly explain it. One idea is that it formed early in Iapetus's history when the moon was spinning faster and material piled up along the equatorial bulge as it slowed down. Another is that it's the remnant of a collapsed ring. Neither explanation is fully settled. The ridge is just there, enormous, symmetrical, and unexplained. Phobos. Phobos orbits Mars closer than any other moon orbits its planet, so close that it actually moves faster than Mars rotates. From the Martian surface, it rises in the west and sets in the east, lapping the planet twice a day. That proximity is what makes it interesting and what's killing it. Tidal forces from Mars are dragging Phobos inward at about 1.8 centimeters per year. That sounds trivial, but the math is unforgiving. In roughly 50 million years, Phobos will either crash directly into Mars or cross the Roche limit first, the distance at which Mars's gravity becomes strong enough to overcome the Moon's own structural strength and pull it apart. If that happens, the debris spreads into a ring. Mars goes from having a lumpy, potato-shaped moon to having a faint ring system, and then eventually that ring rains down onto the planet too. Phobos is already showing what that process looks like from the inside. Its surface is covered in long, parallel grooves, some stretching up to 30 kilometers long and 200 meters deep, running in roughly the same direction across both hemispheres. For a long time, the assumption was that these were ejecta patterns from the large Stickney crater on one end. Current models lean toward a different explanation. The grooves are stress fractures. Mars's gravity is already flexing and stretching Phobos on every orbit, and the surface is cracking under the strain. The moon isn't just falling, it's being pulled apart gradually, one pass at a time, and the cracks are the evidence.